Bonjour à tous. Je vais vous parler
Hello, everyone.
du diagnostic au laboratoire.
I'm going to tell you about bacteria diagnosing highly resistant bacteria, and what about a rapid test that could help us to confirm them and characterize those bacteria. But what does it mean concretely? Let's take the example of treating a sepsis provoked by very common bacteria, which are gram-negative. According to the MSF guidelines, first you should use empirically, before getting the DST, penicillins or cephalosporins, such as ceftriaxone. Should you see in the results that it's resistant to the antibiotics, because you can see that they produce BLSE, well, the second-line antibiotic could be a carbapenem. However, if your bacteria is also resistant to carbapenem because it does produce an enzyme which is called carbapenemase and therefore is a CPE bacteria, well, then you have to fall down on colistin or on other antibiotics, cyclines. And so we are going to focus on these CPEs. They are very recently on the list of very resistant bacteria, and depending on the region, it can be as high as 50%. Mortality can be as high as 50%, and you can find them in hospitals and provoke difficult to treat epidemics. Now, CPE is difficult to treat in MSF settings. The current antibiotics are not really very efficient and also very toxic for kidneys. There are alternative antibiotics, but not available in MSF settings, and we would like to have them in our guidelines for targeted treatment of infection. They are more efficient and safer, but more expensive, and some of them are difficult to get. However, what matters for the time being is that their efficiency depends very much on the type of carbapenemase these bacteria produce. What's the role of a lab in diagnosing these infections? Well, the lab can identify carbapenem resistance and then should be able to confirm that this resistance is due to the production of carbapenemase and then target those enzymes that are produced. There are several classes of these enzymes, A, D, B, and you have here the list of the 5 that are most frequently found in the world. These methods for typing, phenotyping are not available, or molecular identification are not available in MSF settings. And this is very important because the type of CPE identified does condition the type of treatment. So it's very important for the lab to be able to identify the class in question. So we'll look into this very simple lab test, which is called NG-Carba5. It does detect the 5 most common carbapenemases from a bacterial colony, and you can observe 1 line per type. Now, the performance level, as published, is very good. However, it's never been used on African strains, and we think that maybe the performance could be different depending on the carbapenemases that are tested and the organism tested. It can be compared with phenotypic method used specifically in MSF labs for this study, and it could be reused in the future. But it can also be compared with the molecular method, which is the gold standard. However, this whole genome sequencing method is very costly. So our objective is to assess the accuracy of the test to detect CPEs and compare it to reference methods. We also looked at the ease of use and ability for lab technicians to interpret the tests. It's also something that could help us to determine the algorithm for screening and confirmation of CPEs. And also, the study will help us to determine the prevalence and genotypic characteristics of these carbapenemases. This is a retrospective study based on bacterial isolates, which were frozen. We've been working with Beirut, also with the American University, AUB. I'm going to show you the preliminary results. In these 3 labs, we selected gram-negative germs isolated between 2019 and 2021 in Kinshasa and 2024, and we confirmed the DST on Entero and Pseudomonas. We also tested with a carba5 test, and the SIM method questionnaire was filled in by each lab technician after their training and after the end of the study. For Acinetobacter, we use only sequencing since the carba5 test hasn't been validated for them. Here are our preliminary results, and so comparing the rapid test and the SIM method shows that it's in good agreement, both for positive and negative tests. Now, some 70% of these bacteria produce carbapenemases that contribute to resistance. Now, if we look at sequencing, the agreement is still good. However, there are 3 false positive with the carba5 test. For typing, we have shown that in Niger, Jordan, we find a majority of NDM. With the final results, we'll have the performance of the test for each type of carbapenemase. Now, let's turn to Pseudomonas, less frequently isolated in our lab, study labs. Now, here, the agreement is 100%, and you can see that the expression is this one, and these sequencing has shown variability, and we've seen NDM and OXA non-48-like. Niger results are not presented because we haven't detected any resistance to carbapenem yet in our study. The ease of use before and after the study, the lab technicians tell us it's easy to use, easy to interpret. However, the preparation of the bacterial inoculum is perceived as quite tricky, and the CIM method was perceived as difficult for interpretation, for implementation. You have to wait for 4 hours to read the results, and therefore it might not be easy to fit in the routine work of the lab. There's good agreement with reference methods. However, for carbapenemase confirmation, we're still waiting for carbapenemase typing, but it seems that for the OXA line, there are some discrepancies. Now, the ease of use, as reported by the lab technician, is compatible with the routine use in MSF labs. We're still expecting the typing of A. baumannii for carbapenemase type description. Now, with all this, we'll be able to come up with a lab diagnostic algorithm to be defined with or without the rapid test. Of course, we need to optimize cost and time, and also pay attention to the country and the type of organism. However, on the basis of our preliminary results, it seems that it's possible to confirm carbapenemase in our labs, and these are important results to guide therapeutical recommendations, prioritize for potential introduction of new antibiotics, and also have the advocacy and the IPC measures we need. However, there are some limitations because there's no clinical data associated with patients, and we need that in order to have more information on these bacteria resistant to carbapenem. Finally, it's very difficult to generalize our results. We can't use this everywhere. We need to fine-tune our recommendations depending on the context. I'd like to thank all the participants to the study and those who contributed to the implementation in 3 countries, and more particularly for the team in Gaza, because we had planned to implement the study in Gaza as well.